Okay, so we talked about the atom and the basic structure in our last video, but we kind of want to reiterate what's going on. So for a um, little box here, okay, this little periodic table box, we know that the number 8 is the atomic number. We know that the O is our symbol. The word oxygen is the element name, and 15.99 represents the atomic mass. We also know that the atomic number is equal to the number of protons or the number of electrons. And we know that our atomic mass is the number of protons plus the number of neutrons. Now in this video, I went ahead and used the symbol for proton, neutron, and electron. You can write it out if you want, but it takes too much time. So let's work through a sample problem. Okay, we need to fill in the blanks. If you look on your periodic table and you find this blank, or this box right here, number 30, okay, it has the name zinc. The symbol for zinc, if you find it on your periodic table, is a capital Z with a lowercase n. Make sure that your lowercase letters are distinguishable from your capital letters. It's very, very important. The atomic number is 30. The atomic mass is 65.39. The number of protons would be 30 because my atomic number is 30. That also means my number of electrons is 30. Now to figure out my number of neutrons, we're going to round the atomic mass to a whole number because you can't have half of a neutron or 0.39 of a neutron. So if we round this, the 3 is lower than 5, so it's going to stay at 65. And 65 minus 30 is going to give us 35. Now you can complete the rest of this note sheet in the exact same way, but you need to be able to determine the number of protons, neutrons, and electrons from a box on the periodic table. We also want to talk about the atomic structure of an atom and the way you can have different notation. So this notation, okay, is called isotope notation. So this type of thing is isotope notation. Now with this, we can see that the top number, the number 15, represents the mass number, and the atomic number is the number at the bottom, number 7. If you look at the periodic table, number 7 is nitrogen. So we know that we have 7 protons, 7 electrons, and 15 minus 7 gives us 8 neutrons. Now we want to do this for all of the ones in the bottom. So if we look at our problems, let's start with number 1. Hydrogen, if we look on the periodic table, has an atomic number of 1. It has an atomic mass of 1.01. And you'll notice that the mass number is the atomic mass rounded to a whole number. To figure out our protons, we look at our atomic number. There's 1 proton, 1 electron, and our mass number, 1, minus our number of protons, which is 1, will mean that hydrogen has 0 neutrons. If we look at, and we want to complete our symbol too, so we can't just leave our notation as an H. We need to put our mass number, the number 1, on the top, and our atomic number, number 1, on the bottom. If we look at number 2, helium. Helium has an atomic number of 2 on the periodic table. It has an atomic mass of 4.00, and when you round 4.00, or just really take off the decimals, you have the number 4. The atomic number 2 tells me that I have 2 protons and 2 electrons. To figure out my number of neutrons, I would take my mass number, 4, subtract my 2 protons, and get 2 neutrons. And we want to finish our symbol. The symbol has the mass number on top, 4, with the atomic number 2 on the bottom. If we look at a different type of problem, for example, number 8, where they give us our completed symbol, but not anything else, we can use that to figure out our information. We know the number 6 is our atomic number, which also tells us that we have 6 protons and 6 electrons. The mass number is 12, so I can fill that in here. And if I look on my periodic table, I see that carbon has an atomic mass of 12.01. If I would like to figure out the number of neutrons, I'd say 12 minus 6 gives me 6 neutrons. So that is how we would complete these types of problems.